back to another lessons on machine learning hands-on. So in today's lessons, we are going to learn one important pre-processing task or pre-processing techniques in machine learning or data analytics. So write a program to scale numerical features. So all the scaling is applied on all the numerical value features. Features means the columns. Okay. So write a program to scale numerical features using min-max scaling. Okay. So in previous one we have discussed like a standard scaling. Now we are going to discuss min-max scaling with the help of MinMaxScaler class already available in scikit-learn library. Okay, so let's do the some data loading part. Okay, so this was our data loading part. So just copy, okay, and paste it here. Okay, so let's run. Okay, and again method is same, just like the idea is same, just copy paste here. Okay, and now we are going to change the functions. Okay, but the package name will be the same. Okay, but the class name for min-max will be different. Okay, so what is called, just we have to memorize the name and it will be easier to get. Okay, so min-max scaler. Okay, and then after we are already created data set is already there. Okay, and now we are going to identify the numerical column, right? Numerical columns we are going to first select. Okay, so how to select? So df, so suppose first create some numerical variables, numerical columns variables. Okay, fine. Now df dot select d type. So this one is common syntax. Okay, so maybe if you want to select columns, okay, and one flag call include, and that value should be any data type you want to. If there is objects, so it will be return object. If you want to mention numbers, all numerical columns, and then after call the columns. Fine, and then after identifying, now we are going to create the object of min-max algorithm. Okay, min-max. Okay, so how to do that? So first create object called as scalar, and then just we have to call this one. Okay, I'm just going to copy paste just to avoid any spelling mistake or typing error. Okay, and this one, and then after I'm going to apply. So df, we are going to apply it on all numerical value. Okay, equal to scalar dot transform, not transform, it's a called fit. Okay, so fit transform, and then inside here we have to call df the data's frame name and then columns name. Fine, let's run this one. Now after that, now we can print the display the informations. Okay, so df dot head. Okay, fine, so you can see all the numerical columns. So first let me show you what were the data before changing. Okay, so let me add here. So df dot head. Okay, I'm going to rerun from start. Okay, so you can see these are data, right? So you can see there's passenger ID, survivals, survived, P classes. Here we can see these are numerical columns, right? Fares. Fine. So what min-max algorithm basically do, so it's also called normalizations, or it's a very common pre-processing technique you are used in machine learning data analytics. So unlike standardization, this one we have done previously. Okay, so this one talking about, so they are setting the data, all the numerical value data to mean 0 and standard deviations 1. Okay, but here in case of min-max algorithms, with the help of min-max scaling, they are going to convert all algorithm to fixed data. To fix data should be in fixed range between 0 and 1. Okay, so we can see here 1 2 3 4 5, 0 3 1 2 like that. Okay, 1 1 like that. Also here you can see there are some different data, right? So fair data, something like that. So all the numerical data we are going to going to scale between 0 to 1. Okay, so you can see all the divided, all converted between 0 and 1. Okay, so here also you can see. So this is very useful, right? Particularly when the feature have different scale and ranges, right? And you want to scale them to consistency range without distorting their distributions. Okay, so whatever the data have their distribution previous, like before scaling, the same distribution will also have after min max, applying min max scaling. Okay, so it's also preserve the shape of original distribution of the data and maintain relationship between the features. Okay, so after changing this one, so it will be very easier to do our numerical calculation. So that's why we are doing all the important scaling. Okay, so after this one, let's run this one. Okay, and now you can see these are all changes here. Okay, so these are some pre-processing techniques, and also in coming video we are going to discuss more and more. Okay, so I think most of the technique it will be same. First we have to select the columns. Okay, and then after create the object of that scalar, which scaling technique we want to use, and then after just I have to call like fit transforms. In previous one we have seen which were the also fit transform. Okay, so these are common methods. Okay, most of the time will be common, but I think it will depend upon the how they are provided by these algorithms or algorithm the packages. Okay, so that depend upon, but the pattern will be like that. Okay, so scalar dot fit pattern, inside that we have to pass the numerical column data, right? Selecting all the numerical data column, right? Fine. So that's all everyone for this video. I think this video is I'm just going to cover point to point. Okay, so not to the point. I'm not going to discuss any more details about this one. Okay, so that we will more focused on the only focusing on this code. Okay, so maybe in later we can discuss what is min max, scaling technique, all the things we can also discuss later. Okay, so that's all everyone. Or also if you have some doubts, or because we are also, if you are working on some projects, working on some coursework, something like that, and you need some assistance, also you can contact the Codersarts. So we have team of machine learning AI ML experts, so they can help you completing your machine learning projects, assignment, and any other project development work you need to help. Okay, so that's all for today. So let's meet in another one.